Saxon Advanced Mathematics, Lesson 48. Two topics, fairly quick. We're going to talk about powers of trig functions. There's three different ways that we could introduce powers or exponents into trig functions. And I have really exciting news for you. So there's a basic trig function, right? I'm going to write it 3 times. Okay, so there's what we have been using as a trig function. We could put a square there, or we could put a square around the whole thing, or we could square it right there. Now, which of those are we going to use, and how are we going to do it? Here's the good news. This notation and this notation are almost never used. We're not going to explore these because in trig there's really not a reason to square the measure of the angle. Okay? So what these ones are specifically suggesting, we just don't do it. All right? So they're not used. Isn't that a shame? This, however, we have to learn to deal with because this is used quite often. And I want to remind you of something. My youngest daughter studied astronomy at the college level, and she reminds me to remind you that at this point, we don't really know yet what all this trig function business is going to be used for. We're just learning how to manipulate the numbers and the functions so that we can build on it and actually put these to work in higher level calculus, physics, and other applied maths and sciences, engineering classes or astronomy classes, that sort of thing. So you'll learn in future studies what these are good for, but for now, we're just learning how to use them. It's kind of like we haven't started reading Shakespeare yet, but we're learning how to write our B's and our Q's, all right? So we're just learning how to use the tools. All right, so we're gonna learn how to deal with something like this, and spoilers, it's really easy. I mean, to the extent that anything's easy at this point. So here's A. John's doing the A and B thing again, which I'm going to talk to him about someday. I plan to hang out with John when we're in heaven together because, why wouldn't I? Okay, we want to find this is how we look at it, you guys. We're going to find the sine of minus 60 degrees, and then we're going to cube it. All right, that's all there is to it. So let's find the sine of minus 60 degrees. Okay, minus 60 is in the 4th quadrant. So it's going to be like that, right? This is 60 degrees. That's 30 degrees. So let's see our sides. This was the original one. That's what got cut in half. That's what's left over. Sine is equal to Oscar had. So let's take, we're standing here. The opposite side is the square root of 3. The hypotenuse is 2. We're in the 4th quadrant, so let's just review our signs. Plus, 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 minus, plus, minus. I'll just fill it all in so we have it. I'm like a trained seal with this thing. If I need any part of it, I just write the whole thing. Okay, so we've got sine in the 4th quadrant. That is negative. So there's our value. This is just the sine of minus 60, right? How do we cube it? We just cube it. We just take minus square root of 3 over 2. We put it in parentheses, and we cube it. So the sine is going to end up being negative. This is square root of 3 times square root of 3 times square root of 3. 2 go together. 2 pigs on the inside make 1 on the outside. We've got 1 left over. So that's 3 square root of 3. And then this is just 2 times 2 times 2, right? So that's 8. So this is our final answer. So that's all that's new is we find the appropriate value of the ratio as a power of 1, and then we blow it up according to whatever power it is. All right, let's try B. Cotangent squared of 330 degrees. Okay, that's a positive 330, so that means we're down in the fourth quadrant. I'm confusing football with trig. All right, 330, that's 270, so this would mean we have 30 left to go, right? That would get us to 360. That means this is the 60-degree angle. This is the 2, this is the 1, this is the square root of 3. Cotangent is a reciprocal function. It's the reciprocal of, I can write this if I want, right? Tangent, or I can just write, instead of over Arthur, it's Arthur over, in which Arthur gets his revenge. That's what I always think of it as, Arthur's revenge. Okay, we've got this, so now we just need to get our sides. The adjacent side to this angle is square root of 3. The opposite side is 1. The sine, plus or minus, tangent in the fourth quarter is negative. So there's that much. And then I just want to square it, right? This time we're just squaring. And so it becomes 2 negatives make a positive. Square root of 3 times the square root of 3. Our final answer is positive 3. These are right, by the way. I haven't been putting my smiley faces on today or in the last lesson, so fill them in. Okay, that's it. And then these were individual values. Now we're going to do one more problem where we're adding them. So we've been adding trig functions before. We're just going to add trig functions that have powers this time. Ooh, getting so fancy, right? Okay, so since this is a longer problem, John does an A and BS. Evaluate cosecant squared of minus, oh, look at all the booby traps lying in this problem for us. That's what I feel like. It's like a minefield, right? We've got a square, we've got a reciprocal function, we've got a negative value, we've got a value greater than 360. Ay, ay, ay. Tangent squared 45. All right, that one looks way easier. All right, so let's start with the beast. I want to adjust the angle first. At least he didn't give us radians, right? That would be one more little hand grenade he could roll into our path. Let's subtract 360 from that so we can get a good value. Remember the fact that it's a negative here. We don't have to worry about that. We're kind of ignoring that, and we're just basically, we see that this is a coterminal angle. We want to just get the original terminal angle so we don't have that extra spin in there. So that becomes what, 45 degrees, right? Now we take into account the fact that it's minus. Okay, so we want the cosecant squared of minus 45. We see that's going to be fourth quarter, right down the middle. I write the angles in, or the degrees rather, of the angles in, just so that it's very clear which triangle we're referencing, not the 30, 60, 90, but this one. And then that just helps me keep my head on straight as I write the side references in. Cosecant is friends with sine, right? It's the reciprocal, right? The squares don't change any of that old information we have about reciprocal functions. So that means it's going to be ho, right? Because this is Oscar had, so it's upside down, it's ho. The hypotenuse is square root of 2. The opposite is 1. So that's our function. Now we need to square it. Oh, we better get a, well, it doesn't really matter if it's positive or negative because the squaring will turn it positive, right? But let's go ahead and get that. Sine in the fourth quadrant I know is negative. Again, make sure, you guys, there's so much to memorize, and I need you to memorize it for the test. All right? I can pretty much guarantee you that there will be a problem from this lesson, and they're fabulous problems because they bring together so much that we've been studying over the past few weeks. And so they're really lovely from my perspective because I want to see if you can handle all these different bits. But there's so much you have to memorize and understand to get all the pieces in your head moving in. You know, it's like a jigsaw puzzle, right? All the pieces have to fit together. So if you haven't been already, please work on memorizing these. All right, so we're going to square this, and the whole thing is going to boil down to 2, right? Because square root of 2 times the square root of 2 gives us positive 2. The negative times the negative is positive. The 1 goes away. So our final answer is 2. I squiggle it to show that's my answer to this whole thing. So the cosecant squared of minus 405 degrees is 2. How cute is that, right? Okay, this one. And then we're going to subtract. That's what that is, right? Let's make it bigger so it's balanced. All right. Now the tangent squared of 45 degrees, that's a lot easier. We don't have to adjust the degrees. We see it's a 45, 45. It's not an inverse, it's a parent function. Ooh, my 5 went crazy. 1, 1, square root of 2. Tangent is over Arthur. Here we are. The opposite is 1. The adjacent is 1. Tangent in the first quadrant is positive. I like to put the sign there to remind me to check it. That's one of my, it's not a pet peeve. That's one of my mistakes I often make is I forget to check the positive or negative sign of the function. Once I get so excited from calculating it that I forget to check the sign. So I usually put a positive there so that I'm sure that I actually checked it, right? Then this just becomes, it's positive 1, so there's my positive 1. 2 minus 1 equals 1, final answer. How can something that looks so hard generate such a cute little answer? I don't know, but I love it. I find that incredibly satisfying. All right, so that is how we deal with the powers of trig functions. Not that big of a deal, right? Thankfully, something in this trig world that just seems natural and piece of cakey. Piece of cakey. All right, we have a part B in this lesson. It's not too bad, though. It's just one problem, and it's going into geometry land. And the topic is perpendicular bisectors. Huh, fun to say. Let's see what we're talking about. Find the equation of the perpendicular bisector of the line segment whose endpoint coordinates are 4, 2, and 8 minus 3. And it says use the midpoint formula. Huh. The midpoint formula method. All right, well, let's see. Do you remember the midpoint formulas? Please memorize them. They're pretty cute, though, because to find the midpoint value of x, you take the first x and the second x, and you just average them. And then you do the same for the y's, right? So that is a pretty darn easy pair of formulas to memorize, but please do, and remember they're called midpoint formula. Scribble them on the backs of envelopes, doodle them in your gravy on your plate at dinner, use the whiteboard, rice ladies, that you have in your house, write them. You know what I would love is if you took your whole whiteboard and just filled it in with all the different formulas you know. One of you could sit there with your notebook covers and just call out to the other one. Show me the slope formula. Show me the signs of all the trig functions in the different quadrants. And then the other person just has to draw and draw and draw. And then erase and take turns. It would be fun. Okay, so what the heck does this mean? We've got, let's graph it and see what we can get here, right? And I can see it's going to be in these two quadrants, even though I'm not really thinking that way. I need to go out as far as 8. So I'm going to kind of make my graph fit onto my piece of paper. 1, 2, 3, 4, 5, 6, 7, 8. P.S. I decided this time when I prepare my tests, I'm going to write them on graph paper, and hopefully the graph lines will come through in your copy of the test, which may help you if you have to draw pictures. We're doing so much interesting graphing that I want you to have that much structure to your page. All right, let's graph our 2 points. 4, 1, 2, 3, 4, and 2, and then 8 and minus 3. So like that. All right, so this is a segment, right? And what John has asked us to do is find the perpendicular bisector. What he means by that is a line that comes through here. I'm going to do my best to approximate it. It creates a right angle where it touches, and it divides this into perfect halves. My picture isn't half bad, right? Because that does look pretty square. And these two sections of brown, they look sort of the same, right, as those tick marks would show. We're supposed to find the equation of this line. Okay? All right. We can do that. Now, what are the tools we have to do that? John said something about using the midpoint formula. And we could use that. What would that give us? That would give us, if we use the midpoint formula with these 2 points, that would give us the middle of this line, which is right there. That would actually be helpful because that would be a point on our new line, wouldn't it? And we could use that to help write the equation, right? Because we're looking for y equals mx plus b here. So if we use midpoint formula with these 2 points, that would give us that point right there, although it doesn't give us the slope. How could we find the slope? Well, let's see. In order to use slope formula, m equals this one, right? We could do it for this one, right? Because we have 2 pairs of points on that line, but we couldn't use this formula for this line because we're only going to have 1 point. But, if we could find the slope for this line, what do we know about how that would relate to this one? Oh, slopes that are perpendicular, or lines rather. See if you remember this. Perpendicular lines have slopes that are, dun 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 dun, negative reciprocals of one another. You guys, sometimes I can't find my, like 100 times a day I lose my phone. That's because my brain is stuffed full of all kinds of crazy math things. Sometimes I think it's a miracle I remember anything else because my brain is so full of math, which I love. So here's our plan of attack. We use this is slope formula. We're going to use the slope formula. Look at how much knowledge we need to make this problem work. We use slope formula to find the slope of this line. Then we take the negative reciprocal of this line, that gives us the slope of our line, and then we use that slope and 1 point, which we'll get from using midpoint formula, to solve for B on that line. Whew. If you still don't understand, that's okay. Let's just step into it. So step 1, we're going to find the slope of what I'm going to call the segment. Oops, I wrote of twice. Okay, there are the 2 points. So we're going to use midpoint formula right there. My buckets look just like that. I'll call this x1, y1, x2, y2. Okay, y2, -3. y1, carefully filling in, right? I go so fast, I forget to wait for you guys. I'm sorry. Okay. X2 is 8. X1 is 4. Okay, so when we do this, we find it's -5 over +4, right? Which we can also write as -5 over 4. This is the slope of that line, right? So that means that our slope, or our line, m equals, we flip it and we take the opposite sign. So it's positive, I'll put the plus in. Our line has +4/5. Yay! That's really great news, right? We've got our slope for this line. All right, now if we have the slope, then we just need 1 pair of points, and we can use that to solve for B, right? Because this is what we're trying to get. We now know that 4/5 goes in right there. But in order to find that point, we have to use the midpoint formula to get the orange point, right? So that's going to be step 2. And here's what I'm going to do. Well, I guess I can go like this. I've run out of room. I'm going to work here, and then we can flip back and forth as need be. So 2 width. Okay, we're going to use those midpoint formulas with the points that are on the segment to find the middle of the segment, because that point will be on our line as well. And let's just, I'm sorry, pause if you need to keep writing that. Look how messy. Ay, 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 ay. Okay, these are the points. We find the middle, but this point is where the perpendicular bisector runs through, so that it'll give us that orange point that is the intersection of the 2. So I'm going to copy these points, and I'll do the midpoint formulas. I said it twice. The midpoint formulas on the other page. 4, 2, 8 minus 3. You don't have to recopy that if you are working on the same page. All right, so for the x values, this will be the x value of that middle point. It's going to be 4 plus 8 divided by 2. That's pretty easy, right? And then the y will be 2 plus minus 3 divided by 2, which equals -1 over 2. Huh. Okay. We're good with that, right? Just checking to make sure I got it right. Yes, 6 and negative 1/2. Beautiful. Okay, so that means we now have 1 point. 6 and negative 1/2. This is on our line. And then we already have our slope, which I'm just going to copy from the other page. There it is. M equals positive 4/5. Now we can plug in and set up. We still have to solve for b, right? But we can say y equals mx plus b. Y is minus 1/2 equals 4/5 times x plus b. This becomes 24/5, right? 6 times 4 is 24/5. So we have to subtract 24/5 from both sides. Lord have mercy, we have to make our decimals all match. Or not decimals, denominator, sorry. I was looking at this. John works half of this in decimals and half of this in fractions. I am not impressed, John. We are going to do way better than that. This one will have to multiply by 2/2 to get our LCM of 10, right? And this one will multiply by 5/5 to get those denominators matching. So it'll be minus 5/10. And then we're subtracting from it minus 48/10. And that becomes minus 53/10. 53 is prime. And the second, this is, there's my equal sign. So this all cancels, so it's equal to b, right? And so now we take our slope and our value for b, and we write the equation of our line that is a perpendicular bisector of that segment is y equals 4/5x minus 53/10. Love it. So complicated and long, but super fun to use all these tools together to make it work. All right, so that's the equation of the pink line. 4/5x, and John rewrites this as a, he could write this. See, I would be okay with this if he wrote it as 0.8x minus 5.3. I'd be okay with that. But he doesn't. He writes this as a fraction and that as a decimal, and I think that's just ugly and wrong. So we can see that 0.53 is the same as 53/10. That's easy. Okay, yay. Yay for us. There is one more problem. I thought we were done, but alas, John has more in mind for us. But we're almost done. Example 48.4. Write the general form of the perpendicular bisector of the line segment whose endpoints are 4 minus 3 and minus 2 minus 5. Use the midpoint formula again. So what we basically have to do is the same thing all over again, but this time once we get to the end, we're going to write it in what's called the general form, which is that's general form. Okay, so we just have to reshape our answer. We're going to do exactly what we did last time and just reshape the answer. All right. Use midpoint formula method. Okay, that's cool. We know how to do that. So This is the segment that we're starting with. I'm not going to take the time to graph it because that's not necessary. I did it the first time so that you could understand what we were doing, but you don't have to do the graphing in order to make it work. So what we're going to do first is we're going to find, I often refer to the segment as like their segment. It's like, it's not the one we want. We're going to find their M and then our M. Ours is the perpendicular bisector. That's what we're trying to find. So we're going to use the two sets of points that are on their line, x1, y1, x2, y2. M equals y2 minus y1, x2 minus x1. The formula is right there. It's the slope formula. And so y2 is minus 5, y1 is minus 3. Being careful to put these in, and so thankful for my buckets because I got minus signs flying all over the place. So this becomes minus 5 plus 3 equals minus 2. Minus 2 minus 4 equals minus 6. Okay? The two minuses cancel, that reduces. So their slope is 1 over 3. So that means our slope is negative 3 over 1 or negative 3. Oh, okay. I like it, don't you? All right, now we need to solve for B. In order to do that, we need to have one point on our line. So we're going to use these 2 points and the midpoint formula because the midpoint of this segment is where our line is going to shoot through. So midpoint formula, use midpoint formula to find the intersection. I didn't say that last time, but that's the easiest way for me to think about it. All right, so there are our 2 points. So for x, we take minus 2. Well, I can do them in order. It's 4 plus minus 2 divided by 2. So that is 2 over 2 equals 1. And the y value is minus 3 plus minus 5 divided by 2, which equals minus 8 over 2. Making sense? Right? We use those cute little formulas to find, now we know, this is the point that is the intersection, right? Like in our last problem, there was the segment and there was our perpendicular bisector. This is the point right in the middle. It's in the middle of the segment, but it's also on our line. So now, use the slope and the midpoint to solve for B. And we know we're using y equals mx plus b. Y, let's see, where's our point here? Let me write it like this. 1, whoops. That makes it easier for me to see. This way I get confused with which is x and which is y, but when they're written this way, I'm 100%. Y is minus 4 equals our slope, minus 3, times x, which is 1, plus b. Just plugging those in. We've been doing that for days, haven't we? I mean, years, literally. Now we can see this is minus 3, so we have to add 3 to both sides. Minus 1 equals b. So our line is y equals minus 3x minus 1. right? That's the equation of our line, but John wants it in general form. All right, fine. So that means we have to pull all the numbers over to this side, so there's a 0 over there. So we'll add 3x and we'll add 1. Cancel, cancel. So we get 3x plus y plus 1 equals 0. Yay, we got the right answer. All right, so the only wrinkle this time around, plus John gave us way cuter answers. We just had to take it from our slope-intercept format, which we had right here, and we just had to make the final adjustment to get it to general form. All right, that is the end of lesson 48. That is the end of our new material in 2020. You guys, we have had quite a ride, haven't we? I will go over all of the last 12 or 14 lessons for you, working backwards. We'll start at 48. We'll review what we covered, what formulas there are, and how likely it is that you'll see it on the test. That's what I will drop to you on Monday the 14th, and I'll also give you a study plan to help you review for the test. If you have questions, I'll talk to you on Friday and we'll get it all sorted out. Are you ready? I'm pumped. I'm excited, you guys. You have done an amazing job. If you're even just like hanging on by your fingernails at this point, you're doing a really, really great job. So use me as your resource as you prepare for the test, and I will talk to you soon.